Welcome everyone. So today we're going to discuss about ladder operators. So ladder operators are the operators that increase or decrease eigenvalue of another operator. And in quantum mechanics there are two types of ladder operators. One is raising operator and another one is the lowering operators. These raising operators increases the energy eigenvalue and these lowering operators always decreases the energy eigenvalues. And in quantum mechanics, operators are not only used to calculate eigenvalues and eigenvectors, we can also use them to decrease our unneeded calculations and to focus on the essential algebra. Now, as an example, we are going to consider simple harmonic oscillator and we are going to use operator algebra to calculate energy eigenlevels and the associated eigenfunctions. Now, the harmonic oscillator Hamiltonian H is equals to 1 by 2m p square plus half m omega square x square. Now, the basic trick is to introduce two operators in linear combination of x and p. So, here we have introduced two operators a and a dagger. They are defined in this way that a is equals to 1 by root over 2m h cut omega into m omega x cap plus ip cap, and a dagger is defined in this way. They are in linear combination of x and p. So these two operators are known as raising and lowering operators, and why we are calling them as lowering and raising operators, we are going to see that by doing the energy eigenvalue calculations. So now the Hamiltonian operator H can be represented as in terms of a and a dagger in this way. So we can write Hamiltonian operator H in terms of h cut omega into a dagger a plus half, or we may also write it as h cut omega a dagger minus half. Now we're going to consider the commutation relation between h cap and a cap. So h cap a cap, putting the values of h cap in this expression, we get this, and if we apply the rules of commutation, we get h cut omega a commutation between a dagger a multiplied with a and a commutation with a cap and a cap multiplied with a dagger. And since we know from our previous calculation that commutation relation between a dagger is 1, so putting this value in this expression, we get minus h cut omega a cap. So commutation relation between h cap and a cap is minus h cut omega a cap, and similarly we can also calculate the commutation relation between h cap and a cap dagger, which is equals to h cut omega a cap dagger. Now we're gonna use this two commutation relation in our further calculations. Now we're gonna talk about the lowering operator. If u is the eigenfunction of h cap belonging to the eigenvalue e, we can write h cap u is equals to eu as our eigenvalue equation. Similarly, if we consider the commutation relation of h cap and a cap, we know that h cap a cap commutation on u will give minus h cut omega a cap u. Now, if we apply h cap operator on a cap u and a cap operator on h cap u, we get minus h cut omega a cap u, or we may write it in this way that h cap a cap u minus e a cap u is equals to minus h cut omega a cap u, or we can write it or simplify it in this way that h cap operator acting on a cap u will give us e minus h cut omega into a cap u. So as in this equation 1, we can see that u is the eigenfunction of h cap and e is the eigenvalue of u, eigenfunction u. Similarly, here a cap u is the eigenfunction, a new type of eigenfunction, and h cap operating on it will give us e minus h cut omega as the eigenvalue. So here e is decreased by minus h cut omega or lowered by minus h cut omega when you apply a cap on u. So here a cap is the lowering operator. So now from this diagram we can easily understand the lowering and rising operators functions. So in case of harmonic oscillator, psi 0 is the ground state and its corresponding energy is E0. Now if we operate a cap on psi, we get the energy eigenvalue as e minus h cut omega, and if we again apply a cap on a cap psi, we get a cap square psi, and the corresponding energy will decrease again by h cut omega amount. So the energy will be e minus h cut omega minus h cut omega, that means e minus 2 h cut omega. And similarly, if we apply the a dagger operators on the psi, we get the energy eigenvalue as E plus h cut omega, because A dagger is the raising operator, it will increase the energy eigenvalue by h cut omega. Similarly, if we again apply A dagger on A dagger psi, we get A dagger square psi, and its energy eigenvalue will further increased by h cut omega. So the new energy eigenvalue will be E plus 2h cut omega. So in this way, operating A dagger on psi, we can get the higher energy values, and operating A dagger A on psi, we get lower energy values, and E0 is the ground state energy value. So in this way, using the lowering and raising operators, we can get energy eigenvalues of different states. Okay, so this was our discussion on lowering and raising operator, and on our next class we're going to discuss about some other topics. And thank you everyone.